Greetings. My name is Cheetah. I'm a farmer and mycologist based out of Northern California. Over the last couple of years, I've been doing bioremediation research in the wake of urban and forest fires, looking at ways that fungi can help immobilize and hopefully biodegrade toxins in the environment. After publishing some of my results, I've been getting some inquiries about spores and ways that people can apply fungi to the land. In general, we don't really work with spores as mushroom farmers or mycologists. We work from living cultures, the living growing fungus. And so I'm going to share some of just the really low tech, low cost, really basic methods that you can employ in your home, on your small farm, in the wake of natural disaster. Basically just really, really easy ways of culturing fungi. And so kind of the basic unit of mushroom cultivation is something called a spawn bag. So spawn is basically any organic matter that's impregnated with the fungus. Right here, we're looking at the oyster mushroom, and it's growing here on rice straw. Rice straw is great because it's got a high silica content. There's very low competition from other fungi. Basically, our job as a mushroom farmer or in mushroom culture in general is you're trying to create an ideal habitat for the fungus to thrive in. And then from there, it can produce its mushroom fruit body. If you haven't already, go ahead and check out my other videos. There'll be links in the comments below. And that can kind of give you some of that background, but we're just gonna jump into this and knock it out. So the fundamental unit used in most mushroom cultivation is these type of spawn bags. So this is a polypropylene bag. So it's akin to like a turkey bag, a turkey roasting bag, or a shake and bake bag, where it's a quality of plastic that can endure really high temperatures. It's outfitted with this microporous patch. Basically, this is a piece of plastic that will allow the passage of oxygen, but not the passage of contaminants. So the fungus itself can breathe because fungi breathe oxygen, but prevent any competing mold or bacteria from getting into the bag. So this spawn bag is an oyster mushroom. Again, most of these techniques are going to be for oyster mushroom because it's just kind of a tough, tenacious mushroom, and it'll put up with a lot more nonsense than most fungi. So this is an oyster mushroom bag growing on hardwood sawdust. So for a beginning mycologist, it's best to start from something like this. We work a lot with petri dishes and grain in a commercial farming setting, but as a beginning mushroom farmer, you're going to waste a lot of time, you're going to waste a lot of money, you're going to need a lot of specialized equipment. And so what I'm going to kind of outline today is ways that you can jump right in with just a drum or a garbage can and a clean table and begin to grow mushrooms at home. So you can buy these spawn bags commercially, typically about 20 bucks a piece. And what I'm going to encourage you to do is buy your spawn initially commercially. You can get it from any number of sources. Fungi Perfecti notably, buy a lot from Aloha Medicinals. And what I encourage you to get is just a basic elm oyster or a tree oyster. You're probably fine if you're in a higher climate, you work with a pink oyster or maybe a golden oyster, but oyster mushroom is going to be your go-to for getting started. So you purchase this, it comes mail order, and the next step is to expand it, to grow it out, to keep your mycelium spawning onto the next substrate. And so the technique I'm going to outline here is just the expansion from your grain spawn onto these straw bags. So what I've done ahead of time is in my 50-gallon drums over here is I've sterilized this certified organic rice straw in this circumstance. There's a couple different ways of doing this. There's hot water pasteurization, in which you bring water up to, I would say personally, 180 degrees is ideal. In this circumstance, I used a low-tech method that utilizes calcium hydroxide. So this is a form of lime. There's a lot of different things that are called lime. We have dolomitic limestone. We have calcium carbonate, which is basic lime that's used in the garden. You can get lime in the concrete aisle of the hardware store. This is type S lime. That's not exactly the right kind, but in a pinch it'll work. It's got too much magnesium. What you want to go for is a high calcium calcium hydroxide lime. So it's 90% calcium, maybe 10% magnesium carbonate in there. And so what this does, this chemical sterilization that we've used on this straw, is basically it's raised the pH of the material to the level where no other organisms can live. And then what we've done is we drain off that calcium hydroxide solution, and we're left with calcium enriched rice straw. So again, sterility is critical. Everything you want to do is clean. So I'm here in my fancy jumpsuit that I put in the dryer ahead of time. I ran it on high temperature, so it sterilizes the clothing I'm wearing. I'm wearing gloves. It's not always necessary, but it's a good thing to do. And then you want to sterilize any of your working surfaces. And there's kind of two ways to go about this. So we have isopropyl alcohol, basically hand sanitizer. This is 90% isopropanol. Usually when I use isopropanol, I'll add a little bit of water to take it down to 70%. You only really need a 70% solution of isopropanol. If you can get your hands on a good clean ethanol, that's even better. It's better for your respiratory tract and your skin. But isopropanol is kind of our go-to. The one we're going to be using today is your basic germicidal bleach. So in the grocery store, it's typically 5% to 8% sodium hypochlorite. So this Home Depot version is nice. It's 8%, which I like. And then you dilute it 1 to 10 ratio. So 1 part bleach, 10 parts, or 1 part bleach, 10 parts water. And I put it in this little garden sprayer. This is, you know, $10 at the farm store, what have you. And so with this, I sterilize my working surfaces, anything that the fungi is going to come in contact to. You can run a higher solution than 10% if you're going to leave your bleach solution exposed to the sun for any period. You're going to want a little bit higher content. And also it will shorten the contact period. Typically you just need a few minutes of good solid bleach to surface contact to ensure that your working surfaces are devoid of any viable mold spores or bacterium. So I've sterilized my bag here. Again, this is our wood chip bag. This is mycelium impregnated sawdust. I'm gonna go ahead and break it up right now. I've got my sterilized rice straw. Going onto my clean table. You want about a ratio of 10% of your inoculum, your spawn, to your new substrate, your whatever it's going to be. It's going to be your wood chips, your straw bag, what have you. So I bleach the surface of the exterior of my bag. Got a nice clean spawn. Very simply just going to sprinkle it in here. On our farm, we like to use this plastic tubing. So it comes in a big roll, about 14-inch diameter, comes out to about a 10-inch wide roll. This is just what we use, but you can use garbage bags. Any clean plastic bag right out of the gate is going to work for you. So we've distributed our spawn, our myceliated wood chips into the straw. And then very simply, we're going to pack it into this bag. Quick and dirty. You want it packed tight enough that you get good mycelial contact, but not so tight that you suffocate your fungus. Again, fungi breathe oxygen like us, so they need some air exchange in their life to make things work. So as a commercial mushroom farm, we typically pack about 50 or 60 of these per session. We do multiple barrels of straw. Doesn't have to be a 50-gallon drum. You can do it in a fairly clean garbage can when you're using the calcium hydroxide method. A livestock trough, kind of any somewhat clean vessel is acceptable for this chemical sterilization. Again, the alternative method is to bring water up to 180 degrees and soak this straw in a bath of hot water. We call that like pasteurization, basically. But again, when it's the dead of winter, it can be really hard to get a barrel up to 180 degrees when it's cold outside. And in the middle of summer, we're at fire risk, so we don't like to use propane burners. So the calcium hydroxide method is really helpful there. So to create a closure on this bag, I'm just going to rubber band the top of it. Again, our mushrooms require oxygen for life, just like us. And so what we're going to do is we're going to perforate this bag. We're going to put holes in it so that it can breathe for its what we call the spawn run, the duration in which it incubates, in which the fungus grows all the way through the bag. And so here, just a little bit of bleach, make sure everything's clean as usual. Here I have, it's a bed of nails, basically. We've got a bunch of screws running through this cutting board. So what we do, just roll the bag across a couple times. And now our bag is fully perforated and ready for the spawn run. What we do here, really simple, really low tech. We have this sterilized tub. So I've cleaned this with bleach inside and out. And we'll pack 3 to 4 of these into a given sterilized tub. Go ahead and put the lid on it. This is going to go ahead and sit in the barn for 2 to 3 weeks probably. When we come back and we see that it's fully myceliated, we see that the plain old straw is now white and fully covered with that fungus, we know that we're ready to go into our grow houses or out into the world for bioremediation applications if that's what you're doing. So these bags are expensive when you buy them commercially. Like I said, about $20 a piece. If you buy them in bulk, maybe you can get it down to 14. I highly encourage you to grow your own. So what we do here on our farm is we just go from sawdust bag to sawdust bag to sawdust bag. Most of the time we're doing it in the laboratory. We're cooking these bags in pressure cookers at a high temperature, high pressure, so they're really, really clean. You can get away with it though if you just cook them in a 50-gallon drum. So what I done again yesterday was I stuffed a 50-gallon drum, basically put a couple cinder blocks in the bottom of a 50-gallon drum, fill it up to about the level of those cinder blocks with water, and you put a propane burner on there, like something used for home brews or outdoor barbecuing. Basically an 80,000 BTU burner will cut it, and you boil the water in that 50-gallon drum. And what we've done is we stuffed that barrel to the brim with additional sawdust bags. So again, that same polypropylene bag outfitted the microporous patch, the breathing patch, and we let it steam pasteurize. Basically, the water underneath it's boiling and it's steaming out through the top of the 50-gallon drum. I like to run it for 5 to 8 hours, depending on the quality of the material I'm using. If you're getting wood chips from an arborist or something like that, if they're fairly clean, you can get away with that. It's better to use a good hardwood sawdust if you can find it somewhere. So here in this circumstance, we've got a pretty good quality hardwood sawdust, and that's what we're using as our substrate. So by sterilizing this material in the drum and going from bag to bag to bag, if you're relatively hygienic and you try and keep everything really clean, you can continue to keep your initial spawn bag running out and out and out. And a single bag can turn into hundreds, thousands of bags. And so that's kind of how we do it at our farm. So for these, typically what we do is we'll inoculate. Again, about 10% is good. So 1:10 ratio. Spawn, again, this bag is clean on the exterior. I just bleached it. Sprinkle some spawn over. If you have a bag sealer or one of those vacuum sealer heat elements, that's what we typically use to make the closure on this bag. But I've also seen commercial farming operations where just the same. What you're doing is you're taking a rubber band. And I like to fold it over twice if I can. And you're making your closure to your spawn bag that way. I like to apply a little pressure, make sure I don't hear any air escaping. Once it's been closed up, you take this bag and you want to agitate it. You want to take the living growing fungus that you just introduced and you want to move it around this bag. So really vigorously, really quickly. We typically label it with the species and the date that we inoculated. Then this is going to go onto the shelf and sit there for, again, 2 to 3 weeks, typical for oyster mushroom. And the fungus should grow throughout it. And you then have another bag that you can use to expand your fungus even further, either onto the straw or making more sawdust bags. Typically, these bags are sold in a lot of 1,000. There are mushroom supply companies that sell them in smaller batches, or get a hold of somebody who's like-minded or another mushroom farmer or something like that, and you can go together on a batch. But the cost per bag is about 35 cents a piece, and so it's much better than having to spend $20 a pop on spawn bags. So that's kind of the fundamentals that'll get you to growing mushrooms for your own home production. The next kind of component of it, I want to talk about materials that can be used for fungal and enhanced erosion control, or bioremediation practices, or creating outdoor garden beds with fungi. So something that's gained a lot of popularity lately is something called bunker spawn. For bunker spawn, what you're doing is you're inoculating burlap sacks. So you can do the same process where you're pasteurizing your burlap sack in hot water, and then you introduce the fungus to this, you spread it across its surface, roll it up, stick it in a bag, stick it in a garbage bag, whatever you're gonna do. And that works great. Surprisingly, not always easy to get a hold of burlap sacks. And you also have to be wary of, some of them are treated with kerosene to prevent insects from getting into the coffee. So what I've settled on over the last couple of years is using this jute material. So you'll find this in the concrete section of your hardware store. Also, concrete supply companies typically carry this stuff. It's basically a woven organic material, commonly palm pulp. And for whatever reason, fungi have a really, really strong affinity to this kind of woven material in these burlaps. So what I've been taking to doing with some of my bioremediation projects is making full rolls of this stuff. So what we have here is a myceliated jute material. So what I've done is I've taken the byproduct of my mushroom farming operation. So I take one of these spawn bags and I inoculate my larger burlap roll with it, and we'll go through that right now. Again, I'm using calcium hydroxide. So typically for a 50-gallon drum, I'll use about 300 to 400 grams of calcium hydroxide. Again, we're bringing that pH up to a level where it kills all competing organisms, makes it a nice, clean, sterile substrate for the fungus to grow upon. And then after introducing the fungus, again, we put it into a clean bag, give it a couple weeks, and it comes out fully myceliated. And there's 2 ways of going about this. So again, yesterday I sterilized my burlap in calcium hydroxide. Basically, I make, for my 50-gallon drum, I add about 300 to 400 grams of that calcium hydroxide. I let it soak in that solution of calcium hydroxide for 18 to 20 hours and drain that solution off, and I'm left with a clean substrate. So very simple, very easy. Take my burlap material, lay it out on the table. I take my mushroom mycelium. I harvest my mushrooms and eat them. I open my clean plastic bag. And I spread my spawn onto this, and then start to roll it up. So very simple method, not sophisticated at all whatsoever, but it's a way that you can generate a large amount of mycelial mass that is ready to roll out, ready to deploy in the event of a natural disaster like a forest fire or something like that. Can make your own burlap sacks out of this myceliated fabric. So this is a wood chip bag that could be placed in areas of drainage or culvert, or an area where you're expecting a blowout kind of erosion. This material can also be twisted up to make inexpensive wattles. Those are those straw tubes you see used in erosion control on the side of the freeway or after fire events or disturbance, what have you. And this stuff's cheap. A 220-foot roll is only about 70 bucks. And so versus a wattle is going to run you about $30 for a 25-foot segment. So here, got something that's inexpensive, easy to work with, and can be used in a host of different ways. So those are just kind of some of the things that I've been working on lately and wanted to put out there into the world. Feel free to get a hold of me. My contact is below. And then I've got just one more thing for you. As a fun one for kids, or just as a project for yourself, you can do your own bioremediation project by making this coffee spawn. So it's just starting to fruit. You can kind of see it in the corner there. Basically what I've done here is I've taken didn't even clean it, dirty bucket, dropped one of these spawn blocks in the bottom of it. And then just in the morning when I'm making my coffee, I just take the spent grounds and I dump it into my 5-gallon bucket. And once the bucket's full, I take it and I leave it in the garage, leave it in the barn, and the mushroom will actually fully colonize through the coffee because it's a readily sterilized material. By making the coffee, you've already sterilized the material. And so it'll metabolize the caffeine in it for the most part. There is some residual caffeine in there, but it will use all that coffee as an energy source. And it's a great project for kids, just a small way that you can get started doing your own fungal bioremediation, your own fungal culture at home. So I hope this was helpful. Feel free to get a hold of me if I can help you in any way. And may the spores be with you.